of programming in JavaScript. My name is Venkat Subramaniam. We're going to talk about certain ways of programming in JavaScript. Now, let's start by asking the question, how many of you use JavaScript? Well, it's everybody here. How many of you think JavaScript is the best language ever created? Are you crazy? Right? Absolutely not, right? So, this is called Stockholm Syndrome. There's an official term for it. Because you have no choice but to admit it is so wonderful. Because you have to use it, right? That's okay, I feel your pain. So, well, JavaScript has a lot of things that we desire for, it's better. But I want to talk about some ways we can actually write JavaScript and at the end of the day still stay sane. And I want to talk about certain things we can do. Now, I want to start out by saying writing code in JavaScript is extremely easy. But writing good JavaScript is extremely hard. And the whole point about this is to be able to write good JavaScript. Now, why is it so hard to really write good JavaScript? Now, let's be very fair, right? We got part of the blame is on JavaScript. There's no doubt about it. But I don't think we can completely blame JavaScript. So, when you are working on software, how often do you consider maybe going for a training, for example? You consider going for a training for Java, would you? Yeah, absolutely, right? What about for C#? You probably would. How many times would you consider going for training for JavaScript? You rarely do, right? You feel like something is wrong with you if you went to somebody and said, I want a training in JavaScript. Well, let's also think about how do most of us learn? How did we learn JavaScript? We learned JavaScript by looking at code on the web. And what can we say about JavaScript code on the web? Most of them suck. So we use wrong examples. Actually, that was only true about 15 years ago, like Scott was saying this morning, right? We went on from, I don't want to learn from it, and we just copy and paste it. So now we have copy and pasted code with all these anti-patterns moving across that only becomes even worse. So we definitely want to create better JavaScript. So we'll talk about some good practices here to follow. The very first one I would say is use strict. So I'm going to say max equals 100, and I'm going to go ahead and print the value of max. So you can see in this case, it printed the value of max. But I'm going to write a function. So I'm going to say var some function fn equals function. And then within this function, I'm going to go ahead and define a variable var. Let's say, some value v equals 12. And I want to print the value of v. And I'm going to call this function fn. So when I run this function, it printed that. But I'm outside of this function. I'm going to go ahead and print the value v. And what do you expect it to tell you? Undefined. Okay, that's exactly what it said, right? Okay, that's great. But on the other hand, if I were to say max equals 100, and if I said max over here, it printed it. But remember, I did not put the var in front of it. Now, that could be a genuine mistake, right? While you're typing, you don't remember to put a var, or maybe you just mistyped the variable. Does that ever happen? Almost all the time, right? You have a spelling mistake. So JavaScript looks at this and says, aha, this programmer forgot to put var. What's the worst thing I could do to the programmer? And what do you think that is? To make it a global variable. Because nothing hurts in your belly more than that, right? So as a result, it says, ta-da, we'll make it a global variable. So as a result, what's going to happen here is, you're going to come back over here and call max, and you can see that happens. Well, one way to prevent this from happening is, you could say something like use strict. And if you say use strict, immediately it gives an error saying on line number 4, it says, sorry, you cannot use max because you haven't defined it. So the very first thing we can do in JavaScript to save ourselves is to start using the use strict. So that should be like the de facto standard, right, to start using that. Now, as another example here, let's say for a minute, I'm going to say for I equal to 0, I less than, let's say, some value 10, I plus plus, and I want to do some kind of a looping. Doesn't matter what this code is going to do. Let's just take a look at this for a minute, right? I'm going to just loop through this and do some looping. Now, what did I do wrong in this code? The variable I. What is that variable I? It's a global variable. This is a lot of fun. Because if you're in a function and you're in a loop where the variable name is I, and you call yet another function in the loop, and that function has another loop, this is the best way to blow away an entire day at work, right? And after that, you come back and say, why did it not work, right? So absolutely, you don't want to get into that problem. You must have declared as a var. So we can say use strict and say, hey, I want to make sure. So notice how it protects us again and says, don't do that. So use strict can help us quite a bit to minimize those kinds of problems. Well, the next thing to do is we want to always compare values. It is much better to use 3 equals rather than use 2 equals for comparisons. Now, 2 equals unfortunately performs comparison where it actually transforms the object and then performs comparison. So if 2 objects are not the same type, but if the values can be converted, it would still make the conversion and do the comparison. But unfortunately, that could lead to trouble a lot of times because you didn't quite intend it. Of course, if you wrote enough test cases, you will catch that. But I would rather catch these at the code level rather than saying, well, we definitely need more test cases. Sure, you want to have tests, but not more tests because of some problems we can avoid. So, for example, if I say 1 is equal to 1 as a string, you notice that it says true, and that's because of a double equals. Now, of course, if you put 3 equals to, that becomes a false. So you really want to use a 3 equals. And of course, if the values really are equal, that becomes a true, not otherwise. So that's another thing to follow as much as you can when you write it. But let's talk a little bit more about a few other things we can do. Now, when it comes to writing code, we talked about global variables. We should definitely avoid it. You want to keep your variables local. That absolutely is true. However, what about the scope of a variable? Well, unfortunately, in JavaScript, you don't have a block scope. It just simply doesn't exist, right? So if you're writing code, there is no real block scope. So for example, if you were to say something like, for example, you were to have a variable max equals 4, and then you print the value over here, let's say max, of the variable value, so it printed the 4. Then you create a little scope here and you said, v equals 7, and you printed the variable v, and that printed it, but you're outside of that scope and you're printing the variable v. Well, guess what? That didn't make any difference. What did JavaScript do? JavaScript looked at this little curly braces and said, nice curly braces, right? And so I didn't really care about it, right? What a bummer. So what do we do about it? Well, scoping is a really good idea because scope kind of keeps our hands clean, right? So we don't accidentally start changing variables. More than that, there are certain times when you don't want a variable to change because that's none of your business, right? That's kind of the way. What do you call that in languages that support this kind of behavior? Where you cannot access certain variables. The E word. Encapsulation, thank you, right? Encapsulation. Well, how do you encapsulate things in JavaScript? Well, in JavaScript, like everything is public all the time, right? Well, unless you can restrict it to a function scope. So here's an example. Let's say we are interested in creating a function called increment. And what does increment do? The increment function says, here's the function. It says, I'm going to say a counter is plus plus, and it's going to return the value of the counter. So now I can say over here, var counter equal to 0, let's say. So I could come here and say increment. I could come here and say increment one more time, and I could keep calling this any number of times. But unfortunately, I could also say counter plus plus. And that's not going to be fun because you didn't really mean to do it. because you are changing the counter suddenly, and how do you make sure that the variable that you're trying to access does not change to something you never expected it to change to, right? So minus 22, for example. That's going to mess up a lot of stuff for you. So in other words, how do you make sure that you don't really give permission for this counter to be modified, without any control? So this is a very interesting pattern you could use essentially as a way to gain a bit of encapsulation in a language that doesn't quite intend to provide it. So this is called an anonymous closure. So what's an anonymous closure? An anonymous closure is a little funky when you look at it. So what you do here is you first of all say function, and then you write a function. And within this function, you move this code right inside of that. So now you can see you have the function defined here, and you have a counter defined, and you know this is a local scope. You cannot access this outside of this function. And then you define an increment function within this function, but when you are done, you simply return the increment function from this function. So what does this function do? This function simply becomes like a factory of this other function, but the counter becomes a completely hidden scope within this function. And then when you're done with it, you can simply invoke that function, and that becomes your increment over here. In fact, you can simply say, rather than doing all of that, you can simply say return here, and you don't even need to provide that particular variable. So now I can say output, for example, increment, and I can call it. I can also call increment one more time, for example. But if I were to say counter, well, I don't have access to it because it is in the hidden scope. So this could be another way that we can work through as a pattern, and this is a very common pattern you notice almost any time you are using a library in JavaScript. Because the library folks are saying, well, we want to protect our own code, we want to just not make our variables so easily accessible, so that's a very common pattern. It may not be as short as this, but it could be several functions you create, and then you may ship all those functions as simply a JSON object, and then on the receiving side you can say, well, here's a group of functions I've received, but everything that's being dealt with internally is their business. So this gives a nice separation of the data that you need internally to the functions you want to use on the outside. So that can be a very nice way to provide this. So that is an example of how you can use an anonymous closure. Now I want to create a class. Now how do I create a class in JavaScript? Well, here's a class I'm going to create, var car equals function, and right there we created a class called car. You say, wait, you just created a function. No, we created a class. Well, how in the world would you say it's a class? Well, did you not notice the uppercase letter here? Well, that is a convention in JavaScript, right? That's a convention in JavaScript because this convention says my intention here is not to use it as a function. My intention here is to use that function as a constructor. So in JavaScript, you never actually create a class. In JavaScript, you always create either a function or a class factory, which is a constructor. So you create constructors or functions, you never actually create a class. So now that we have a little object here, what should I do in this case? Well, I could say, for example, miles, for instance, and I could say this dot miles equals the given miles. I could set it. So now I could say var car equals new car 10, and I could say car.miles to get access to it. Now, in a very similar way, what we talked about earlier, one of the problems in this code is you could say car.miles equals -2, and then you could say car.miles. I don't know what that means. Maybe you drive in reverse for too long, right? I don't know. So, but you don't want this to happen, right? You don't want to be able to change it. Well, one way you can facilitate that as a pattern again is you could simply say var, for example, and then you could say distance equals miles, and then of course you don't have access to that right here. You cannot access miles from outside anymore because that's not part of the object. Well, then the question is, oh, wait a minute, but how do I really drive this car around, change the distance? Well, let's say drive, for example, and I'm going to say equals function distance. And in this case, what do I want to do? I want to say the distance is distance plus equal to the given distance. And then I could say, for example, this dot, let's call it as, a distance traveled, for example. And you could ask for the distance it's traveled and say function. And this could again, in turn, return to us maybe a value which is return the distance that it's been traveled. So how would this work then? Well, you start with a little miles value to begin with. That's the first start. Then I could say, give me the value for car.distance traveled. And you can see that in this particular case, the distance traveled should be returning to us a value, which is the value 10. But that's a local variable in that context, isn't it? Now that we have that particular value, we could say car.drive, and I could say drive 20. And then I could ask for car.distance traveled, and you can see that in this case it can change. But of course, I can't really do car.miles because there is no such property called miles available for us to access it. So we can again apply the similar pattern here if you are interested. However, let's deviate from that for a minute. Let's say we are creating a class called car, and I'm going to say this dot miles, for example, is equal to the given miles. Well, now that we created it, one of the things that JavaScript does, in fact, this is probably the best feature in JavaScript. I can't imagine a better feature in JavaScript than this, which is called the prototypal inheritance. Unfortunately, because of the clutter and the confusion that JavaScript created, one of the best parts of JavaScript somewhat went undiscovered, right? Which is kind of really sad, isn't it? This is like having such a wonderful feature, but we don't even exploit it or even appreciate it as much because of all the confusion we normally have. But prototypal inheritance essentially says that my object is going to inherit from a prototypal instance. So a sample object is provided and you're inheriting features from it. So this is like you are going to have a chain of objects, and then you're going to say, if I don't have a property with me, I'm going to go get the property from this prototype, which is a very powerful inheritance model. Well, unfortunately though, for that we need to really talk to a prototype. So to talk to a prototype, there are two different options available to us. One, you could put this function that you are interested in this instance, or you could put this function into the prototype. But it turns out that in JavaScript, any number of objects of a class share the prototype. So if you look at this for a minute, if I were to create two objects of this class, so I say car1 equals new car, and I'm going to say car2 equals new car, also 10. Now I'm going to say car1 is triple equals car2. You can see it's false because those two are not two different, they're not the same instance. However, if I say dot prototype, and I'm going to ask for the prototype of this is equal to the prototype of that, and you can see the prototypes are actually the same. So multiple objects of the same type share the prototype. So rather than trying to put the function in the instance, if you were to put the function in the prototype, then the function gets reused among the objects, giving us the illusion of a true inheritance model or a class hierarchy model that can be pretty powerful for us to use. So for that reason, what we would normally do is we would say, in this case, something along the lines of car.prototype.drive, for example, equals function. And then in this case, what would you do? You would then say, once you have created this, you would say, well, now that I have a drive function, it's going to take a distance as a parameter that I'm going to pass in this case, and then I'm going to simply say this dot miles plus equal to the distance, and now you can come back here and say car1 dot drive, let's say 10, and then you can say car1 dot miles, and you can see that it's actually still working. But this drive function becomes part of the prototype for us to use. In a very similar way, we could say var car2 equals new car, let's say 1 mile, and then car2.drive, let's say 10, and then of course we ask car2.miles, and that better have traveled 11 miles, and you can see that's actually the result in this case. So we can start putting stuff into a prototype as we are creating a class. Now, this is again a departure from what we normally do in other languages. And what do you normally do in other languages? You create a class, and within that you put everything inside of that, and that's a nice modular code. Whereas here, things kind of begin to spread out across, right? And that can become a bit painful. You got to remember the details, and that can become quite ineffective over time. So one way you can solve that particular problem is by refactoring just a little bit of code. So notice how I'm going to refactor this code here. The first thing I'm going to do here is I'm going to say var, and I'm going to say class equals, and I'll say create class. And create class is going to be a function I'm going to create first of all. So let's go ahead and say create class equals function. And once I create this function, what am I going to do within this? I'm going to say var class equals function. And I'm going to simply return the class. So that's all I've done so far. So in other words, what I just did here is I just took that code and I moved it across, right? Let's not worry about the property for now. We can always bring that back in. So that's all I did. So now I want to simply say, well, I have a car class, so car equals, and I can simply say create class, and I can simply call that. So now I could say var car equals new car, and you can see I'm getting an object of this car, so we could say car, that's an object. But I want a function in this car. How do I add a function to it? Well, here's the next thing we could do. We could pass some functions. So we could pass a property called functions. And so now I can come here and say, well, here is my function. Let's call it drive for a minute. And I'm going to say this is function. And all I'm going to do is simply say driving. So now what's going to happen? Well, I've provided a little JSON object for it to receive. And it's going to say, oh, you want this drive function to be added to this particular class. All right. Well, maybe I want to do another function also, right? So maybe I want to add to this not only the drive function, but maybe a turn function as well. And then I'm going to say function here, and then maybe don't worry about the direction of turning. So I'm going to say turning. So we have two functions, turn and drive, which we've been adding to this. So how do we go about using that? So now that we have created a little function here, before we go any further, let's say for a minute for, and we'll say for function in functions, and let's simply output, for example, just the function we have on our hand. So you can see drive and the turn being sent in here. So that's a first step. But now that we have the functions we are receiving, rather than printing it, let's say that we have the class on our hand. Let's go to the prototype, and here comes a charm. Rather than saying dot something, JavaScript has a wonderful way to do something else, which is either you can define a property like this, or you can say class.prototype square bracket and then something as a string. So this gives you the flexibility. If you don't know the name of something, you don't have to use a dot notation, use a square bracket notation to get to it, right? So this can be a very powerful model because you don't know the name at this level. So what you can do is you can say class.prototype, a square bracket fn equals functions, that function you are interested in, you're assigning it to the prototype. So now that you have done that, what's the next step? Well, we are done with adding the functions now. Let's come back here, create this car. We have a couple of functions on it. Let's say car.drive, for example, and call the drive function. And we can also say here is our car.turn, and we can call the turn function. Now it's a question of building upon this to start adding properties, but what did we achieve by doing this? What we achieved by doing it is, you can put this into a little library and you can start using this over and over rather than having to sit there and fiddle with all this concept of prototype and stuff like that. Now, especially this is important because every single time you have to work on the details, there are two problems. One, you have to think about how to really do it correctly. And second, you have to make sure you don't really mess up while doing it. But if you refactor that into a function, you have worked really hard in getting it right once, and you can take Scott's advice and write test on it. Now that becomes a reusable code. Now you don't have to worry about really having to think through that several times. That becomes a reusable code, right? And if you look at other libraries that are JavaScript libraries, oftentimes that's exactly what they do, is they create these functions and reuse them quite a bit. So this becomes like a factory function, if you want to call it that way, that you can use. But that brings the question, okay, we are able to isolate that into a nice little thing and streamline it. That's awesome. But what if we want to use inheritance? Well, inheritance in this concept is a little different than inheritance as we are used to in Java. In Java, inheritance is really inflexible. It is static. Once you inherit from a class, you are stuck with it, right? So you can change inheritance once you create it. Inheritance in JavaScript is extremely dynamic. So in other words, you can inherit from one class, and during runtime, you can switch your inheritance to another class. Now you may say, why in the world do you want to do it? Well, one of the reasons is, if I'm depending on a base class to provide some function, from the testability point of view, I can simply, at a particular test case, quietly switch my parent class to a mock object, and I can run test on it very easily, right? So this can be extremely powerful to flip what you're inheriting from. You can change it at the instance level if you want to. That can be extremely powerful. So, but how does this really work? Well, essentially what's happening is, when an object doesn't have a property, it goes and gets into the prototype. So all you have to do for inheritance is take an existing object's prototype and simply make it your prototype or an instance of that. But one thing you have to be careful about this, a common mistake. You don't add functions to your prototype and then switch your prototype, right? That is like trying to be on the top of a tree and trying to cut the bottom of the tree, right? That's not going to help really well. So what you really want to do is, you want to first assign your prototype, and then you want to start injecting methods to that prototype. But this is again a thought process we have to go through to make sure we don't mess this up. Again, you can isolate this really nicely. So notice what I'm going to do here. I'm going to go back to this code and say, here is a vehicle, and then a car, and the vehicle contains those two functions, and this is going to be a vehicle v, and I'm going to say this is my vehicle, and I'm going to just call these methods on the vehicle. That's all I have so far, right? So that's great. But now I want to create a class called car. So the first thing I'm going to do is go back to this and say, comma base. Notice I run this code and it still works. And the reason for that is JavaScript is extremely generous. You can have as many, that's the only way to explain it, right? So there's no other way to be polite about it. So JavaScript is extremely generous. You can take as many parameters as you want to take, but all that matters is what people are sending to you. And if they don't send you a property, what does it do? It says, well, it's undefined, right? So in other words, JavaScript kind of treats you like a guest in its house. Right? If you're visiting somebody's house and you put a coffee mug here, they don't say, don't put it there, right? They kind of look at you, they smile and say, stupid person, put it here, and they quietly take it away, right? JavaScript exactly says the same thing about us, right? Stupid programmer didn't send this parameter, it's undefined, right? So that's exactly what's happening in this case. So as a result, that base over here, I didn't pass it. It's like, I don't care, you didn't pass it. Now what am I going to do? Well, before I start putting stuff into the prototype, I'm going to say if base is not equal to undefined, right? Undefined. Well, what do I do? Well, this is the cousin, the opposite of the equality, the not equality. And I'm going to say something like base given for a minute, right? Base given. And clearly it didn't say base given, as you can see. Now I can come back here and say, well, var car equals create class, and I'm going to provide a couple of different functions. A property a car can definitely benefit from is to break it, and I'm going to say function. And in this case, of course, I'm going to say just, let's go ahead and say stop. And so I have added a function, but what am I going to do after this? I'm going to say vehicle. So I'm going to pass a base to this particular function. So you can see base given now, right, for the second one. So now that I have a base given, what am I going to do? Well, if you gave me a base, I'm going to say class.prototype is equal to object.create base.prototype. So I'm asking it to say, well, if you gave me a base class name, I will make a copy of that object's prototype. I'll make an instance of that object's prototype, and I will store it. Why are you making an instance? Because you don't want to mess with the original, right? It's your own business because you want to add more functions to it, so you made a copy from it and said, I'm going to add my own functions to it. It's extremely important you do the step before you come down to inject methods into the prototype. If you do it in reverse, you added all the functions and you throw it away, right? You don't want to do that. So now if you come back to this code, what's going to happen? Well, I'm going to come back here and say this is car equals new car, and I'm going to now say here is our car, and you can see in this case I'm calling those two functions, but I say car.break, and I'm calling the new added function, which is the break function. So again, you can streamline some of these and eliminate all that. So yes, JavaScript can become very messy, but a little bit of a discipline can help us a great deal to deal with it and stay sane by refactoring all these complexities into a fairly well-written, well-tested code, and then we can start leveraging that and reusing it. So that is another thing I would suggest. And one more thing I want to mention here before we go further, and you could call this as a pattern if you want to call this. So I want to call a particular function that does some wonderful work. So get stuff from remote or whatever. Well, this particular function, get stuff from remote, requires 3 functions as a callback. One you call with a return value when things work properly, and one that you call when something went really wrong, and maybe a third you would call, I don't know, whatever that could be, right? So you got 3 different things you want to call. So what do you want to do here? Well, you would say function, and then data, and then you would start writing the code for it, right? So the code for it sits right here. And then you say comma function, and then you have the error, isn't it? And then you have the code for it sitting here. And then, of course, comma function, whatever that other is going to be, and then you're going to have code for it. So that's the code that you have for that. Has anybody seen code like this before? Yeah, a few people reluctantly raising their hands. That's it? Only that many people have seen the code like this? Well, the other people have lost their sense after looking at it. They don't even have memory anymore, right? That's how torturous it's been looking at it. Now, I'm sure you read this code the first day. What did you do? You came with this innocence that only a child would have, right? The first time you looked at this code, what did you do? You came in and said, oh, get stuff from remote. How sweet. Oh, I got a function. And you start reading every single line of code, and then you see this curly brace and say, wow, that's great. That function is done. And then you see the comma. That's like somebody stabbed you in the back, right? You look at this and say, what now? And then it pours down on you, you're going, and then that's over, and then it's a comma. And you are quietly looking around. It's like, is somebody just teasing me with this, right? That's an example of a very bad code, isn't it? And we have written code like this forever. But JavaScript, okay, for all things we can blame JavaScript for, JavaScript doesn't tell us do this. There's a devil in each of us that says do this. And when the devil combines with JavaScript, it's a disaster, right? That's the problem we are having. So what we need to do is we need to have a deep conversation with us. It's okay, you don't have to do this, right? And so it's very simple. One of the things I would recommend doing is simply say var, for example, success equals function, and then you write this function which is going to be dealing with the data, and that becomes your success function, right? Whatever that number of lines of code is. Now, first of all, if you do this, you get one direct benefit of writing this function. What would that be? If you don't answer, Scott will answer. Testable. Exactly, right? It's easier to test it separately. You don't have to test that piece of code by going through all this hoopla, right? You can simply take that function and say, hey, here's a sample data. Are you working, right? Becomes testable. It's easy to test it separately, right? Absolutely. Then similarly, you can say var error equals, or error handler, whatever we want to call it. And then you could say error, and then you could write that function, whatever that function is. And you can finish writing that code, and that could be testable too. Var other, whatever that other means, and you could say, I'm going to handle that separately as well. Now that you have written all of that, you can come down here and you can say success, error, and then other. Isn't that sweet? When you just look at that function, you look at it and say, okay, that makes sense. Now, why don't we write code like that, where you look at the code and you say, that makes sense? I'll tell you why. Because if you write code and your colleagues look at it and say, yeah, I understand it. It works. You feel really sad. You feel like you're not important at work, right? And you think, maybe they'll fire me because everybody understands my code. So you come back and say, I've got an idea, a deeply rooted job security, right? And then the company says, whatever you do, don't touch this employee because the code that person writes, nobody understands, right? So deep down, we write bad code because we feel good about it. We really have to change that behavior, right? And we should start feeling good about writing better quality code than writing poor quality code. That's extremely important, and not have those ulterior motives. So that is another example of how we could change this. Hey, what about the singleton pattern? Now, this is one of the other things I want to say, is sometimes we get carried away and we try to implement solutions that really is not that important. This is one of the things I love the most, to pair with somebody else. And I can't tell you how many times I sit down and start pairing, I come up with this wonderful idea that I'm absolutely proud about. If you notice, my bottom is not even in the seat. I'm floating with pride, right? And I would say, how cool this is. And the gentleman next to me or the lady next to me would say, well, yeah, but why do you need that? And you look at them like, what do you mean, don't you see why you need it? And then they say, well, how about refactoring this? It solves the problem. We don't need all that stuff. And then you realize, well, why did I go off to create all that nonsense in the first place, right? So let's look at one example of that. So that's why I'm going to call this as take one and take two. Now, can somebody tell me what is singleton pattern? Ensure you have only one instance of that. Well, it turns out singleton pattern is the easiest pattern that takes forever to implement correctly, because it introduces so many problems in it, right? It's a very troublesome pattern, because you think you got it until somebody comes and says, what about now? You're like, damn, you broke it. And then you go back and put. And then what do? You keep adding a little bit of code, and there's a technical term for it. It's called scotch tape driven development, right? And then when you're done with it, your code looks like bandage all over. You're like, what happened to you? Did you run in front of a bus or something, right? The code looks like that. So how do you really fix it? Well, let's take a look at an example here. What I'm going to show you here is a very clever code. So var singleton equals function. Now this function says, I'm going to have a singleton dot prototype dot foo equals function, and we will simply say over here output, let's say foo called. So now I'm going to say var, let's call it s1 equals new singleton, and var s2 is equal to new singleton, and I'm going to say s1 dot foo, and I'm going to say s2 dot foo. Of course, you can see those two are being called. But the most important question to ask here is s1 the same as s2? And the answer is no, it's not. So it's not a singleton, even though I called it a singleton. So how do you really make sure it is a singleton? Now, you know this thought, right? As a programmer, you sit down, you're trying to solve a problem, and you're struggling with it, and suddenly you're pause coding, and then your face brightens up, and you're like, cool, I just figured a very clever way to do this. And your excitement is uncontrollable, right? Because at this point, only you know what this is. But trust me when I say this, when you have a clever idea, only you will ever know what it is. Nobody ever gets it. So that's the problem with clever code, right? So you say, I got a great idea here. I'm going to say in here, var instance, and I'm going to create an instance. And we can apply the pattern we saw earlier about the anonymous function, right? So it doesn't have to float around, outside. But you can say if instance is equal to undefined, what do you do if it's undefined? You could say, well, instance equals this, right? You could set the instance if it is undefined. Then you can say return instance. So in this case, notice it said true. But look at this code for a minute. What did you just do? Within this constructor, you said, hey, thanks for calling. I'm not going to use the object you just created. Instead, I'm going to return a singleton. You should feel morally wrong at this point. Not like, oh, this is amazing, right? Look how I exploited the language. And somebody comes along and they stare at this and say, what in the world are you doing? And you look at them and very proudly, isn't that cool? They're like, no, it is not, right? There is only a fine line between clever and crude. And this is really a crude code in my opinion, right? Because you're exploiting a certain behavior in the language, and you always do this thing until 3 weeks later somebody finds a problem with it. What do? More Scotch tape after that, right? But if you really think about it, what was your goal after all? One instance. That's all you wanted, right? If all you wanted is one instance, why go through all this trouble? Right? Why go through all this trouble? Let's try this again. Var singleton equals, so I created a little JSON object. And I'm going to go get rid of all that stupidity and simply say over here, here is my foo, and this foo is a function that has that value, right? Then I come down here and say, well, singleton.foo, and I'm going to call the method on it directly. Hey, it works. Why should I really go through all the singleton? Now, clearly there's one problem with this code, right? You cannot impress your friends with this. You cannot go to them and say, isn't this cool? Yeah, it has to be. I don't have a clue what you're doing. This is also better, right? Sometimes you hire interns to work in your companies, right? Sometimes you do that, right? What do the interns do? They come and work for a month, and they go back to the college and say, you know the company I interned with? These guys are awesome. I understood nothing of what they do, right? So that's the way we create a myth. And what do they do when they graduate? They say, when I grow up, I want to be evil like them, right? So again, this becomes a vicious cycle over time. But if you create something simple, they're like, oh, I can actually understand this, right? And they ask you, am I stupid because I understand it? It's like, no, you actually are intelligent because you can write code like this, right? And that's what we want to promote. No need to really go through that extent. Well, we looked at that. What about the strategy pattern? Well, we could use the strategy, but we could use strategy at the function level rather than using this at the class level. So let me give you an example of this strategy here. Let's assume for a minute you are working on a late Friday evening and you are going to meet some of your best friends after a very long time, and you are absolutely eager to go meet them. Your thought is completely on meeting your friends, not in the code you're writing. Well, the job on your hand is, given a list of values, we'll call it numbers for a minute. So I have numbers, and you can say equals to 1, 2, 3, 4, 5, and 6, and you're told total all these values. So you're going to say total values, and you're going to pass the numbers, but how do you implement it? Well, you're going to simply say a function, so var total values equals function. And then what are you going to do within this? You're going to say var result is equal to 0, and you want to return the result when you are done, of course. So that's a 0 right now, but you could say for variable I is equal to 0, I less than, we could say numbers dot whatever length, and then what do you say? I plus plus, and you say, well, result is plus equal to, oh, in this case, numbers square bracket I to get the value out of the collection. So you got that working, right? Well, you look at your watch, it's getting really late, you want to go, but unfortunately one of your colleagues comes to you and says, hey, not only want you to write this function to total all the values, but I want you to write a function that totals only even values. You say, you mean something like this, total even values? You say, yeah, absolutely, that's what I want, your colleague says. Well, you look at your watch again and you realize it's getting late, but there's a bit of a good news already. Most of the code you need is already there, right? Look at the beauty of this code. It starts with a collection of data that's coming in. it is, actually I should have passed this as a parameter. Let's do that. So this is going to be, let's call this as values over here. And I'm going to pass these values here so that I don't get confused with it. And this is the numbers coming in. So almost all the code we need is already done. And you look at this and say, this is absolutely phenomenal, right? Almost all the work is done for us. And the code says, well, you get the values, you initialize the variable, loop through the values, total the value, this is awesome. And then you say, well, but the code I want is only a little different from this code. And then you look at your watch one more time and you tell yourselves, there's got to be a reason why they created copy and paste, right? I mean, if nobody should ever use it, would they create copy and paste, right? So you reason that and say, copy and paste it, even values, isn't that beautiful? And then you say, if the number at location I mod 2 is equal to 0, then total not otherwise. And then you're asking it to loop through the values and print it. And of course, you pass the values to this, and it's done. Isn't that beautiful? Well, then you say, a few minutes later, your colleague says, I want you to total odd values also, please. Now you know you're in trouble. Because copying and pasting code a third time is an act of criminal negligence. But I got some good news for you. It's Friday night and nobody is looking, right? So you can copy and paste it one more time and get this going, right? So isn't that beautiful how this works? So odd values, and you simply say this is not equal to, and of course that's equal to, and guess what? It's working. Well, then you leave the office. On the way, as you're moving around, guilt immediately kicks in, right? Because you didn't really work this hard to start writing code like this. So you pull up by the nearest coffee shop, you try to refactor the code, but as fate may have it, some of your other friends are hanging around, they ask you what you're doing, and before you could shut your laptop, they look at your code, and they get to know your dark side. Right? They no longer return your phone calls or your text messages, because who wants to hang out with a person who does copying and pasting for a living anyways, right? So life kind of becomes dark over time, isn't it? So how do we really make sure this doesn't happen? Well, let's get back to this for a minute. Pretend that this never happened. So we have this code, and your colleague comes to you and says, I want to not only total the values, but I want to total only the even numbers in this collection. Well, a time for a little refactoring. So what we're going to do here is we're going to say values, comma, and we will say accept all. How about that? Little accept all. So what in the world is this accept all? Well, this accept all is just a function I'm going to create. So accept all equals function. And here's one of the beauties of JavaScript. It doesn't care if you don't use parameters given to you. So you could be, the caller could be sending parameters to you, but if you don't care to use it, JavaScript doesn't complain. So you don't have to really put any extra things there, just return true, accept all. I don't have to say anything more in this, right? So what's going to happen now? I can go back to this code and say, comma, I'll take a predicate. Now I can come to this code and say, if the given predicate, taking the value numbers I, is happy, then total not otherwise. Now you can come back to this code and say var even only equals function, and then you can say in this case, well, I'm going to take a number that is being given to me, and I'm going to say return number is mod 2 is equal to 0. So I've written a little even only function. Now what can I do? I can simply say over here as simple as total values, comma, even only, and that can be the call that I make here with just the even values. So if your colleague now comes to you and says, hey, I need a function that totals only odd numbers, you tell your colleague, go back to your desk and do it yourself, because I've provided a reusable function for you, right? So as a result, you can see you don't have to duplicate this anymore. You can simply say this is odd only, and you can reuse that pretty much, that function, by writing an odd only. And you could say odd only equals, of course, in this case, you could say, well, rather than comparing for the value equality, I'm going to compare for inequality and do it. So that essentially is like a strategy pattern, except we are using these anonymous functions to get the work done, and we can make the code a lot more reusable, as you can see, by using some of these constructs. Well, the last thing I want to show you here is something that can help us to improve the fluency of the code. Now, fluency of the code is where we want to really call multiple methods to set up a certain state in the object, and so we normally end up writing code like that. So, for example, I want to say, let's say we have a class I want to create. So in this case, I could say mailer. This is one of my favorite examples of how you can make the code fluent. And of course, if I had kept my other code for creating a class, I could have used it here, but this is going to add a little bit more flavor to it. So I have a function here. What am I going to do? Well, I have this mailer on my hand, but what am I going to do with this mailer? I'm going to say mailer.prototype dot, and I'm going to say from. And the from is going to be a function I'm going to create, equals function. And in this function, I'm going to say, well, I'm going to say from called, right? So I could say from called. And of course, you're going to pass some data to it, maybe an address. That could be the address given here. Similarly, you could say to, and that could be an address and to called. Likewise, you could specify a mailer.prototype, and this could be a subject you are passing to this, right? So this could be a subject, and what would the subject be? Whatever the subject is, could be a line that you're passing to the subject. And so on, you could start putting things like this. Now, when you start writing code like this, what would you normally do? You would say mailer, and you would create an object of this mailer, right? So you would say new mailer, and you would create a mailer object, so mailer equals. Then what do? You say mailer dot, and you would say from, and you would specify some data for the from. And then mailer dot to, and you would start specifying the data for the to. And mailer dot, let's say subject, and pass the data for the subject. So you can keep going like this with each of the calls, and that would be the sequence of things you would normally do. But the more you keep adding, you can see the noise that is getting built up in this code. What you can do to avoid this is you can change things just a little bit. Wouldn't it be nice if we can simply say mailer, and then we can say dot from, and then we can simply say dot to, and then we can start lining these up, and then we can simply keep going. Well, if I run this code, it fails. Why? Because I couldn't call the to on this. What's the reason for it? Well, it was a result, nothing returned for us. But we can try to change this to say, well, from the from, return the current object for me, please. So we can say return this. And likewise, we could say return this in each of these functions. And now we can start to chain this. There are two names for this pattern, for fluency. One name is called the Cascade method pattern. So you're kind of cascading through and implementing it, and you're basically using the Cascade method pattern. Another fond name for this is called the train wreck pattern. It's like a train wreck, and one thing fails and everything else falls apart after that, right? But you can start writing code like this, and then you can remove the noise in the code, and you don't have to keep repeatedly calling that. It becomes a nice sequencing that you can pile up on, and you can carry the state through. And along the way, you could even change the object you're working with, right? So along the way, based on a certain state, you can return either one object or another. And here comes the charm. The type of functions that are available in the downstream could actually vary depending on what's happening through. And JavaScript being a dynamically typed language, you can change things at will, so it doesn't have to be the same flow every single time. It can be very contextual as well. So when you start playing with some of these ideas, you can not only write code that's easy to understand but easier to maintain also, but you can also start writing code that's fairly elegant and easier to work with, and that gives a lot more power to us as programmers, and that's definitely a place where you want to be. So I showed you a number of patterns here that you could use, but anything we can do to make JavaScript better is something we should do, and especially for a language like JavaScript, it needs a little extra help from us for it to be really better, and we should definitely take the time to do it. I hope you found that useful. Thank you.